Number 11. Number 11 says, the point on the curve x squared plus 2y equals to 0, that is nearest point, 0 and negative 1/2 occurs where y is. This everything is given, and what I did here was, from this equation, I just turned it into y equal form. Now, because it says the nearest the point, so we have to find the distance formula. So it will be d equals to radical square roots and x minus 0, which is x minus 0 squared plus y minus 1/2. So plus 1/2 squared. Now, because we made this equation y equal to, we can substitute this function or this equation to this y. So, changing in, I'll just write x squared plus this negative 1/2 x squared plus 1/2 squared. Now, one thing you have to notice is you don't have to do all the hard stuff here, just playing with square roots. You just need to think. Because we're solving for nearest point, we need a smallest value. And to get the smallest value, you just need a smallest value inside of the square root. And the smallest value inside of square root will make the smallest value possible for square root. So, plugging in g of x, I set the g of x for this equation, this function, and by simplifying this function inside of the square root, it will become 1/4 x to the 4th plus 1/2 x squared plus 1/4. Now, let's use second derivative test. I just write 2dt or second dt. So, through second derivative test, we can first make this g prime and set it equal to 0 and find the critical point. And after finding the critical point of x, we can do another derivative and set it equal to g double prime x and plug this critical values, and if my negative number comes out, it will be maximum, and if positive number comes out, it will be minimum. And we're searching for minimum right now. So let's do this. G prime x will equal to 3 plus x. Then this cancels out because of the constant. And I will set it equal to 0. So to the third plus x equals to 0. And now obviously this is 0. So x equals to 0. Now, let's do another differentiation to make g double prime x, which will become 3x to the squared plus 1. If we plug in 0 here, like this, positive number will come out, which is 1. And because this is positive number, we can see, oh, it is minimum. So, now, because this is 0, and we have solved that this is the minimum critical value for this function, for the nearest or the minimum distance, we can plug back into this original equation, which is y equal to negative 1/2 0 squared. And now we get the y value, which is 0. So an answer to this problem is 0. Choice B. Number 12. Number 12 says if f of x is equal to this integral, then f prime x equal to what? So, you've noticed this, there's a variable here, and we have to solve for f prime. Then you right away have to think, oh, it's second fundamental theorem of calculus, which is d dx integral g of x. This is any variable like this, and any numbers. Fx dx is equal to, already at the bottom, is f of g of x times g prime x. So now let's use this second fundamental theorem of calculus to solve this problem. So from this will be the fx dx, but we just use dt, and from here this will be the x, 0 with the number. So it will be negative e to the minus, and we just plug in the number because it's f of g of x. So x squared times g prime x, g prime x, g prime x, which is 1. So this problem was really simple for you. The answer will be minus or negative e to the negative x squared. And choice for this number is e. So e will be the answer for this problem. Number 13. Number 13 says the region bounded by the x-axis and the part of the graph of y cosine x between x equals to negative pi over 2 and x equals to positive pi over 2 is separated into two regions by the line x equals to k. If the area of the region for negative pi over x between negative pi over 2 and k is 3 times the area of the region for x between k and pi over 2, what is k? So, because we're talking about the area, we have to make the equation of integral. So, integral, and the first region gave us is negative pi over 2 to k. Negative pi over 2 to k. And the function cosine x dx is equal to. Now the next region will be k to pi over 2. However, it is given that this region is 3 times the region of between k and pi over 2. So we will write 3 times k to pi over 2 cosine x dx. Now it's our turn to just solve for this. So if we integrate cosine x, it will become sine x. K negative pi over 2 is equal to 3 times the sine x pi over 2 to k. Now, sine k minus sine negative pi over 2 is equal to 3 times sine pi over 2 minus sine k. Now, let's solve for this. Oh, sorry about this. It'll be, because sine is negative pi over 2, we just have to think of unit circle. So for messy circle, however, because this is pi over 2, this is pi over 2 minus pi over 2 will be this. So, which is equal to 3 pi over 2. That will equal negative 1. So, it will be sine k plus 1, right? Because it's negative 1 times 1 minus or negative becomes positive 1 equals to 3. This will be 1 because now it's not negative, positive 1 minus sine k. Now, sine k plus 1 equals to 3 minus 3 sine k. And it will become, if we move the negative 3 sine k to here, it will be 4 sine k, and move the constant here, minus 2. And now, I'll erase the top part because of the space. I'll erase the top part. And I'll just move this equation to the top, like that. So, because it's 4 sine k equal to 2, it will be sine k equal to, because we move this 4 at the bottom, because dividing by each side, it will become 1/2. And think, which value here, which value from here will sine equal to 1/2? Wow! It will be either pi over 6. And let us look at the options. Yes, for pi over 6, so sine pi over 6 is equal to 1/2. And choice C will have this answer, 1/2. So, when you see the problem of area, you just have to think about integration. number 14. Number 14 says, if y equal to x squared plus 2 and u equal to 2x minus 1, then what is dy du? So right after seeing dy du, you just have to think, oh, it's differentiation. So y is equal to x squared plus 2, u is equal to 2x minus 1, and we have to think dy du. But this problem is a little tricky because it is dy du, not dy dx nor du dx. It is dy over du. One trick you have to think is, let's see the variables we have. We have y, u, and x, right? X contains in both equation and y is here and u is here. So let us think. From this we can set, so first ignore this part, dy dx, by just differentiating this. And we can think of this as du dx, right? Because we can just differentiate this to make this equation, differentiate this equation to make this equation. So now think, from these two, how can I make dy du? Reciprocal, you're right. So dx over dy, so ignore this part. Dy over dx times dx over du, du, we'll cancel these two out and make dy over du. Now let's do it. By differentiating this, it'll be dy over dx equal to 2x, and differentiating this, it'll be du over dx equal to 2. Now, because I said reciprocal, dx over du will be 1/2, and everything's done. You just have to multiply this because this 2 will cancel out, so it'll be dy over dx times dx over du is equal to, cancels out and makes dy du, what we want and what the problem asks for, is equal to dx times the reciprocal section, which is 1/2. So is equal to, this 2 cancels out and becomes x. And for this answer, choice is D. So the answer for number 14 is D. Thank you for watching, and I hope this video was helpful.